If you actually used 100% of your brain at once, you would not become a genius. You would have a seizure, and you might not survive it. That's not a metaphor. That's the literal textbook definition of what a seizure is. So before we get to why, let's kill the myth underneath the question, because it's not true, and the real story is stranger than the myth. You do not use 10% of your brain. You never have. Nobody ever has. Brain scans, fMRI, PET, going back decades, show activity across nearly the entire brain over the course of an ordinary day. Movement, vision, memory, language. Different regions, constantly trading off, but essentially all of it gets used by something, regularly. There's also a simple evolutionary argument nobody needed a scanner to make. An organ that expensive, sitting 80% idle, is exactly the kind of costly waste natural selection ruthlessly cuts down over generations. If most of your brain genuinely did nothing, evolution had millions of years to shrink it. It didn't. That alone should have killed the myth decades before the scanners did. The number is usually blamed on Albert Einstein, supposedly explaining his own genius. There's no record he ever said it. No paper, no letter, no interview. It's a fabricated quote attached to a real name because it sounded more convincing that way. The actual origin traces to 1907, a psychologist named William James, writing that people use only a small part of their possible mental resources. He was talking about willpower and untapped effort, not brain tissue. Somewhere across a century, the metaphor calcified into a fake anatomical fact. Hollywood ran with it for decades afterward. Films built entire plots around a character unlocking the unused 90% and gaining telepathy, or total recall, or superhuman focus. Good premise for fiction, just built on a number that was never true to begin with. Here's the detail that actually explains where the 10% number came from, and it's the real hinge of this whole video. At any single instant, only around 10 to 20% of your neurons are electrically firing at once. The old myth wasn't entirely made up. It measured something real. It just measured it wrong and drew the wrong conclusion from a correct number. All of your brain gets used, just never all at the same moment. There's a real difference between unused and off-duty. So why not switch more of it on at once? Wouldn't that just make you smarter, faster? Two reasons, and the first one is basically a budget. Your brain is about 2% of your body weight. It burns roughly 20% of your body's entire energy supply, just idling, just keeping the lights on, while you sit still doing nothing in particular. That's already the most expensive organ you own, by a huge margin, and it's spending that fortune at rest before you've asked it to solve anything. Skeletal muscle, by contrast, makes up around 40% of your body weight, and at rest barely sips energy in comparison, only spiking hard when you actually move. For comparison, your heart, working around the clock for your entire life, uses a fraction of that share. Push activation higher, and the metabolic cost doesn't rise gently. It rises fast, faster than any benefit you'd realistically get back from it. Your blood vessels physically cannot deliver enough oxygen and glucose to run much more of it simultaneously. The plumbing is already close to its limit, permanently. The second reason is more interesting than the budget, and it's the one neuroscience only nailed down properly in the last few decades. Most of your neurons are excitatory. Left alone, they'd happily set each other off in a chain reaction. Neuron, triggering neuron, unchecked. What stops that from happening constantly is a separate class of cells, inhibitory neurons, whose entire job is to slam the brakes on the excitatory ones. They fire more or less continuously, specifically to stop the excitatory network from synchronizing into one giant, indiscriminate pulse. Your brain isn't a system that's mostly switched off, waiting. It's a system that is actively, constantly restraining itself from switching fully on. Now break that restraint. Force synchronization instead of letting the brakes do their job. Large groups of neurons start firing together in lockstep instead of each one handling its own separate, specific job. That is precisely what a generalized seizure is. Runaway synchronized firing, spreading across the brain. It's not a metaphor for what 100% activation would look like. It is what 100% activation looks like, observed directly in hospitals every day on monitors. During a seizure, the brain isn't doing more. It's doing the same handful of things everywhere at once, which in practice means it's doing almost nothing useful at all. So a maximally active brain wouldn't outthink anyone on the planet. It would briefly lose the ability to think in any organized way whatsoever. Consciousness itself depends on different regions doing different things at different moments, not the same electrical event happening everywhere simultaneously. Total activation isn't enhanced intelligence, it's the temporary erasure of the exact thing that makes intelligence possible in the first place. Which flips the entire original question upside down, and this is the part almost nobody expects going in. If maximum brain activity is a medical emergency, what does higher intelligence actually look like inside a normal working brain? Researchers have been scanning this directly since the 1980s, comparing measured brain activation to measured intelligence on the exact same tasks in the same subjects. And the finding keeps replicating decades later across different scanning methods. Smarter brains, on average, show less activation solving the same problem, not more. Scientists call it the neural efficiency hypothesis. A brighter brain routes a given task through a smaller, more targeted set of circuits and leaves the rest quiet. A less efficient brain recruits a wider, noisier spread of regions to solve the exact same problem, most of it unnecessary. Chess is one of the clearest examples researchers keep coming back to. A novice studying a board recruits broad, effortful activity across the whole visual and reasoning network, working the position out piece by piece. A grandmaster looking at the exact same position often shows a smaller, quieter, more localized flicker of activity. Pattern recognition built from experience, doing in an instant what the novice's brain has to labor through. Same board, same correct answer, most of the time. Wildly different amounts of brain lighting up to get there. More firing isn't a sign of a harder working brain. Very often it's the opposite signal. A brain working less precisely, burning more fuel to arrive at the same answer. There's a real nuance here worth being honest about, because the finding isn't absolute in every condition. On genuinely difficult tasks, right at the edge of someone's ability, that gap can narrow or even flip as sharper brains ramp up focused effort to match the challenge. But across the range of ordinary, everyday thinking, the core pattern holds up consistently. Efficient beats loud. So intelligence was never really about how much of the brain lights up on a scan. It's about how little needs to arrive at the right answer. The brain that uses less, precisely and selectively, beats the brain that uses more, indiscriminately, almost every single time. Which means the pop culture fantasy has the entire mechanism exactly backwards. Unlocking 100% wouldn't unlock some hidden reserve of power. It would be the single fastest, most direct way to disable the power your brain already quietly has. So here's a real question worth sitting with, because it isn't just trivia. If real intelligence means using less of your brain, more precisely, is unused potential actually the wrong goal to be chasing at all? Some people spend years trying to think harder, push more raw effort, force more activation, as if volume were the point. What if the entire aim should run the opposite direction? Not more activation, better targeting, not a louder brain, a quieter, more efficient one, doing less and hitting more. Where do you land on it? Is untapped potential really sitting there waiting to be switched on? Or was that whole framing broken from the very start? It's a genuinely different way to think about self-improvement, and it cuts against almost everything marketed at you about unlocking your mind. Because somewhere, right now, someone is trying to force their brain to do more, all at once, convinced that's what genius feels like from the inside. It isn't. Genius is quieter than that. Quiet enough that from the outside it can look like the brain is barely working at all.